Good morning. This is the lecture for M100 Basic Mathematics, Thursday, September 3rd, 2020. We are going to talk about section 6.6, which is graphing linear equations. In your book, this is on page 327. And again, I expect that by this point you should have your book. Some of what we're going to talk about is review. In fact, most of it is probably review. It's something that you've seen at least once before. But some of you probably struggle with graphing lines, and so I'm going to walk through the process. After we do some initial review, I'm going to walk through the process and teach it to you as if it's new material. So first thing I want to talk about is the idea of what it means to graph and how we do our graphing. So I'm going to pull up on my iPad a picture of, some of you would call it graph paper. Some of you would call it a X and Y plane. And what I want to do is I just want to talk about what these parts are and how they make up what we call the Cartesian plane. So I want you to understand that when we graph in 2 dimensions, and this is 2 dimensions, we have 2 lines that are perpendicular to one another. This line right here is called the x-axis, and this line right here is called the y-axis. And we graph everything relationally on the x and the y-axis. We always start at the point where they intersect right here. And that point where they intersect is called the origin. By the way, I don't know why it keeps flashing in and out like that. It's doing that on my iPad and showing up on the screen, so I'm sorry about that. But anyway, the point where those 2 lines intersect is called the origin. And of course, we know that an origin is a starting point. If somebody were to say to you, where are you originally from? You know, they're asking, where were you born? So an origin is a starting point, and I encourage you that whenever you are going to start graphing points, you put your pen or pencil at the origin and you move from there. Now these 2 axes, that's the plural of axis, these 2 axes are essentially number lines. And you're familiar with the horizontal number line, the x-axis. The vertical axis, the y-axis, is just another number line that goes up and down instead of left-right. And of course, we know that the number line as it goes to the right is positive, as it goes to the left is negative. When the number line goes up, it's positive. Oops, hang on a second. It's positive, and when it goes down, it's negative. So we're going to graph points. Sometimes they're called coordinates in the Cartesian plane. And a point is also called an ordered pair, and it might look something like this. So I'm just going to write an ordered pair up here. I'm going to put the point 3, 5, okay? And we want to graph that point 3, 5. Now the thing to understand is that the first value is your x value and the second value is your y value. It is really annoying that it keeps cutting in and out like that. I don't know why it's doing it, and I am sorry. But anyway, we're going to graph this point 3, 5. The way that we do that is we look at the x value, and if it's positive, we move to the right, and if it's negative, we move to the left. And once we've moved the appropriate number of points, spaces, we apply the y value. We'll move up or down. So I'm starting with an ordered pair that has positive x value and a positive y value. So again, we start at the origin. I'm going to put my pencil right there at the origin. And then we're going to move 1, 2, 3 units to the right. And then we're going to move up 1, 2, 3, 4, 5 units. And that's the location of the ordered pair 3, 5. It's just that simple. Okay. I'm going to close this out and open up another one. I don't know if it's going to keep doing those flashing things. But we're going to graph a couple of other points just so that you're familiar with what it is that we're doing. So let me open another one and we'll take a look and edit. Come on, there we go. Looks like it's doing that same flashing thing. Let's say that we want to graph the point, and I'm going to use some negative values now. So let's say that the point, the ordered pair is -4, 2, like so. Okay, so again, we put our pencil down at the origin, and then we're going to move 4 units in the negative direction, and then we're going to go up 2 units, and that is the point -4, 2. Now sometimes we'll label our points, we'll name them, so we might call that point point A, and so we could put an A next to it in the graph and we would know where it was. Okay, so let's graph another point. Let me do a different color this time. Let me do it in green, and we'll call that point B. I really don't like the way that this is showing up. Oh, I see why. Maybe that's why. So point B, let's call point B -2, -5. All right. So now from the origin, we would move 2 units to the left because our x values are negative, and then we would go down 1, 2, 3, 4, 5, and that would be the point, and it's named B, so we would write a B there. You don't have to show the movement. You don't have to include all of the hopping to the left and then going down. So, oops, did not mean to erase all that. There we go. So if you didn't include this moving, sorry, trying to get used to the eraser. If you didn't want to include the showing this movement and you just did the move on your own, that would be perfectly fine. Okay. So what if, let's look at another point. We'll call this point point C. I'm going to try a different, let's see if this works better. Yeah, I think I like that better. Let's say point C is 0, 4. Okay. So when we start at the origin, and by the way, the ordered pair that represents the origin is 0, 0 because you don't move to the left or the right or up or down. So let's say that you start at the origin and you're going to graph 0, 4. Well, the x value is 0, so that means you do not move left or right. So you don't move left or right, and then you move up 4, 1, 2, 3, 4, and that is the value, that is the ordered pair for C. If we had, let's look at something, let's look at letter D. Let's do one more. Let's say we have a letter D that is -3, 0. Well, now we start at the origin. The letter, the first number, -3, tells us to move 1, 2, 3 units to the left because it's negative, but then we don't move up or down, so we stay right there. So that point right there would be letter D. And this should be review. Graphing these points should be a simple review for you guys. Pardon me for drinking iced tea, but I am very parched. Anyway, this is something that you should know how to do pretty simply, graphing these points. This shouldn't be a lot of heavy review. But you need to be able to graph the points in order to graph lines, which is what we're going to be shooting for. So we're going to start looking at the bottom of page 329, and we're going to talk about the section that says graphing linear equations by plotting points. And so what I'm going to do is I'm going to pull up a clean sheet. Let's take a look. Oh, that's the one I just did, my bad. Pull up this one. And we're going to graph a line by finding points. So let's start with something simple. Let's start with the equation. I'm going to use the equation that they use on page 329, which is this one right here. Let me get my, come on, open up here. So I'm going to use this marker because it seems to be what works best. Let's look at y equals x plus 1. Okay, the equation y equals x plus 1. So what that means is that when you pick a value for x and you plug it into the equation, you're going to add 1 to it to find out what the corresponding y value is. And to find points, what you can do is you can create something that is called a table of values. Just make yourself a little cross like that. Put the x on the right side. I'm sorry, and the x on the left side and the y on the right side. And then we're just going to pick some values for x. And you can pick any values that you want. I wouldn't get ridiculous. I wouldn't pick really, really large values, but I might consider picking 0 whenever I can. 0 is helpful. Maybe 1 and -2. I'm just picking those at random. And what I'm going to do is I'm going to take each of these values, I'm going to plug them in to the equation for x, and I'm going to find the corresponding y value. And we can do these in our heads. This is pretty simple. So when you see y equals x plus 1, if x is 0, then y is going to be 0 plus 1, which is of course 1. So that gives us an ordered pair. Because the x was 0 and the corresponding y value was 1, we have the ordered pair 0, 1, which is something we can easily graph. Now we're going to do the same thing with x being a positive 1. So 1 plus 1 is 2. So that gives us the ordered pair 1, 2. And we'll be able to graph that. And then we do the same thing with letter x and the third value. -2 plus 1 is -1. So that gives us the ordered pair. X is, oops, my fault. Sorry about that. X is -2. Y is -1. And now we have 3 ordered pairs. Now, the question is often asked, how many points should we graph to graph a line? And I would encourage you that in general, graphing 3 points is a good idea. I know that you only need 2 points to form a line, but if you compute one of them wrong, then you'll possibly make a mistake, which is not good. So if you pick 3 points and they all line up, then you know that you've done it correctly. So now what I'm going to do with those 3 points, and I hope that you will remember them because I'm going to slide down here. I'll slide back and forth like this. I'm going to graph those 3 points. So the first one I'm going to graph is 0, 1, okay? So remember, we start at the origin, so I'm going to put my pen at the origin. And then 0, 1, the x value is 0, so I don't move left or right, but then I move up 1, and I put a point. So that's the first point on my line. The next point is 1, 2. So again, I'm going to start at the origin. I'm going to move 1 unit to the right, and then I'm going to go up 2 units. I don't know why it's suddenly drawing in yellow. I must have accidentally hit that. So I move 1 unit, and then I go up 2 units, and there is another point on my line. And then the third point was -2, -1. So again, starting at the origin, I'm going to move 2 units to the left, and then I'm going to drop down a unit, and there is my third point. And you can see that those 3 points do form a line. Now, you need to draw them, and you need to connect them with a straight line, and I'm saying that, and I don't have a ruler. I'm going to grab a ruler out of my desk drawer right here, and I'm actually going to put it on my iPad because I want to draw a straight line. I want to model that for you. So there we go. So that's the line. And of course, we put arrows on the end because a line continues in both directions without end. If you don't put the arrows, I'm not going to count it wrong. But that's the line, y equals x plus 1. And we found that by plotting points. We picked some values for x, we plugged them in, we solved for y, and we got that line. Let's do another one. So if you have your book on page 330, I'm going to demonstrate example number 3. Let me pull up a fresh page. Oh, that's the one I just did. I'm going to have to keep better track. Here we go. And we're going to do the equation y equals 2x plus 2. I'm going to try, I've got all sorts of stuff on my desk here as I'm trying to operate from a smaller desk than I'm used to. I'm going to write this equation up here so that we can, I'm not going to scroll all the way down because then we have to keep bouncing back and forth. So I'm going to go ahead and, come on, there's my smart annotation. It keeps defaulting to red, which I don't like. Go with that. With that. So here's the equation, y equals 2x plus 2. All right, so we're going to create a table of values. There are my x values, there are my y values. By the way, when an equation is solved for y like this, where it says y equals the x value plus or minus something like that, that is a very useful notation. That's called slope-intercept form. When you get the equation solved for the letter y, it's very easy to find ordered pairs because you just pick random x values, you plug them in, and you generate a y value that'll show up on the right, left side of the equation. So I always like to show x is 0. That's always one of my preferred choices whenever I can. Some people like to let y equal 0, and we'll look at what that looks like in a little bit. But I'm just going to pick some other random values, and I'm proving to you that they're random because I'm not picking the same ones each time. So now what if I let x equal 2, and what if I let x equal -3? So I just picked those at random. 0 wasn't necessarily at random. And I'm going to plug these values in, and I'm going to find out what the y value is. So we can do this in our heads, simple arithmetic. So when x is 0, right here, start here, we plug the 0 in for x. 2 times 0 is 0, plus 2 is 2. So that gives us the ordered pair 0, 2. Pretty simple. Now, when x is 2, we'll move to the next ordered pair. 2 times 2 is 4, plus 2 is 6. So now we have the ordered pair 2, 6. That's driving me crazy, that flashing in and out. I don't know why it's doing that, and I am sorry. And then when x is -3, be careful here. 2 times -3 is -6, and -6 plus 2 is -4. So those are 3 ordered pairs that we can plug in to our graph, and they should form a straight line if I've done my computations correctly. So again, starting at the origin, graphing the first point, 0, 2, I don't move left or right, and then I go up 2. So there's my first point, 0, 2. My second point, starting at the origin, I'm going to move 2 units to the right, and then I'm going to go up 1, 2, 3, 4, 5, 6. There's my second point. And then -3, -4, starting at the origin, I'm going to move 3 units to the left, and then I'm going to go down 1, 2, 3, 4. There's my third point. And as you can see, I'm grabbing a ruler here so I can draw a nice straight line. But as you can see, these points form a straight line. That is the picture graph. That basically graphing a line is drawing a picture of the equation. That's exactly what graphing is. And that's the equation of, that's the picture of the equation y equals 2x plus 2. All right? So at the top of page 331, they give us a process for graphing linear equations by plotting points. And the first step that they recommend is solving the equation for y. I strongly recommend that you do that. It's a lot simpler. In fact, I'm going to show you one here in a little bit where we're going to solve the equation for y. Before we get started, I'll show you one that's not in the book. And so solve the equation for y, select at least 3 values for x and determine their corresponding values of y. We just did that. Plot the points, and the points should be in a straight line. Draw, here's the key, draw a line through the set of points and place arrow tips at the end of, at both ends of the line. If you graph the points but you don't connect them and form a line, I'm not going to give you full credit because you're graphing a line, you're not just graphing the points. So make sure that you can do that. All right, so let me go ahead and pull up one that is not in your book and show you exactly what it looks like in terms of solving solving for y first. Let's see, we'll go to this one. So I'm going to have to do this down low because we're going to have to do a little bit of computation here. So let's say we have an equation like, come on, where are you at? There we go. Change that, change that. What if we have an equation like 3x plus 4y equals 12, okay? This is a good equation for us to work. It'll graph nicely. But I'm going to show you some real nice tips that'll make this graphing a little simpler. The first thing we want to do is we want to get the y by itself. So obviously we need to subtract 3x from both sides. And when you do that, over on the right side, I'll show you in a minute what I want you to do, but these are going to cancel. So I'm going to be left with 4y equals. Now on the right side, I want you to put the x term first. We're going to put the negative 3x first and then a positive 12. And the reason that we do that is because we're putting it in that form I told you about called slope-intercept form, and we'll talk about that more in an upcoming lecture. The next thing we're going to do is we're going to divide both sides by 4. Notice I'm dividing all the terms by 4 because I want to make sure I divide every part of it. So those cancel, and I'm left with y equals negative 3/4 x plus 12 divided by 4 is 3. This is the equation that we're going to work with. And I know you're thinking, oh, Mr. Becker, I don't like working with fractions. Why did you have to get fractions in there? I'm going to show you a real nice way to solve this where you don't have to worry about the fractions. So the next thing we're going to do is we're going to create that table of values, x and y. I always like to use 0 whenever I can for x. And now I need to pick 2 other values for x and find their corresponding y values. Now here's a little tip. Excuse me. When you have a fraction in front of your x, the values you choose for x need to be multiples of the denominator. Let me say that again. When you have a fraction in front of the x, the values of x you want to choose are multiples of the denominator. So what are multiples? Well, multiples of 4 would be like 4, 8, 12, 16, 20, and so forth, right? Negative 4, negative 8, negative 12, negative 16, negative 20. And the reason you want to pick those multiples is because they will cancel out the fraction and you'll be left with a nice integer solution. You could pick 3, for example, but then you're going to get an ugly fraction, and trying to graph a fraction is kind of a pain. So the easiest values to choose, and I'm a big advocate for doing it as easily as possible, the best values to probably choose are 4 and negative 4. All right? Now, when I put a 0 in for x, and we can do these in our heads, we should be able to do these in our heads. When I put a 0 in for x, remember, the x value right here, I'm circling it, I'm going to erase that circle, but I'm reminding you, we're going to put a 0 in there for x, so that's negative 3/4 times 0. And of course, anything times 0 is 0. So negative 3/4 times 0 is 0, plus 3 is 3. That's a really nice ordered pair that we're graphing. Okay, now, when we put in the 4, we're going to put the 4 in right there for x, okay? So 4 times negative 3/4. I'll show you what we're looking at here. 4 times negative 3/4. Well, the 4's cancel, don't they? And you're left with a negative 3 plus 3 equals 0. So when you use 4, you get a 0. So we've got the ordered pair 0, 3. We've got the ordered pair 4, 0. I'm going to write it underneath here just to remind us. Okay, that's the second ordered pair. That's the first one. And now we're going to put in the negative 4 right there for x. Negative 4 times negative 3/4. We do it the same way as what we did in the previous problem. Negative 4 times negative 3/4 plus 3. Well, the double negative cancels, right? And so I'm left with 4 times 3 is 12 over 4. 12 over 4 is 3 plus 3 is 6. So my third ordered pair is negative 4, 6. So there's my 3 ordered pairs. And I didn't have to worry about any ugly fractions because I picked multiples of my denominator. So now, if you're following along, I want you to jot those 3 ordered pairs down because I'm going to scroll up and we're going to graph them. I'll probably have to scroll back down to remind myself of what they are, but if you just write them down, then you can refer to them. So the first one is 0, 3. So we always start at the origin, we don't move left or right, and then we go up 3. So we've got a point right there. That was nice. The next one is 4, 0. So starting at the origin, we move 1, 2, 3, 4 units to the right, and then we don't move up or down. And then the third ordered pair is negative 4, 6. So we start at the origin again. Negative 4 from the origin would be to the left 4. And then we go up 1, 2, 3, 4, 5, 6. And there's our third point. And I think that you can all see that they are in a straight line. Grabbing my trusty ruler here, I'm now going to connect those 3 points with a straight line and put arrowheads on them, and I've graphed the line. All right, so that's how we graph a line by plotting points. Now, there are some points that we can graph that are kind of special points, and we're going to look at this graph to understand what they are. So I'm going to change my color here to red because I want to highlight these 2 points. This point right here and this point right here are very special points. And the reason that they're special is because they're crossing an axis, okay? The point right here is crossing the y-axis, and this point is crossing the x-axis. Whenever a point crosses an axis, we call that point an intercept. If you're familiar with football, you know what an interception is. If you're familiar with warfare, you know that an interceptor missile is a missile that's supposed to hit another, a plane or a rocket or something like that. Basically, when we talk about intercepting, we're talking about things crossing, okay? So when we talk about an intercept in graphing lines, we're talking about the place where the line crosses the x or the y-axis. And they're called, appropriately enough, this is called the y-intercept because it is the place where the line crosses the y-axis. And this one is called the x-intercept, okay? Every line will have an x-intercept and a y-intercept as long as it's a slanted line. We'll look at some examples of horizontal and vertical lines where they'll have one intercept or the other, but not both. But any line that is slanted will always have an x-intercept and a y-intercept. Now, I want to remind you of what's important here about these 2 intercepts. The ordered pair for the x-intercept is 4, 0. And the ordered pair for the y-intercept is 0, 3. Yep, 0, 3, like that, okay? What I want you to notice is that whenever you have an intercept, one of the values in your ordered pair will be 0, and this is always the case. In fact, whenever you are looking at an x-intercept, y will always equal 0. And whenever you're looking at a y-intercept, the x value will always equal 0. Okay? And you can see this on page 331 in your books. Determining the procedure for finding x and y intercepts, it says that to determine the x-intercept, set y equal to 0 and solve for x. And to determine the y-intercept, set x equals 0 and solve the equation for y. So what I want to do right now is I want us to take a look at this exact same equation for a moment. Just going to move down here. And instead of picking the points at random, what I want to do is I want you to understand that if we let x equal 0, let's look at the, well, I'm a little bit out of space here, so I guess I can do it right up here. Okay, so let's look at the equation y equals -3/4 x plus 3. If you let x equal 0, that's going to zero out that term right there. It's going to make it equal 0 because 0 times the -3/4 is 0. And then, of course, 0 plus 3 equals 3. So when x equaled 0, y equaled 3. Conversely, when we let the y value equal 0, -3/4 x plus 3, if we were to solve this equation for the letter x, we would get that x equals 4. So when y equaled 0, x equaled 4. In other words, you can find these 2 points. Instead of graphing 3 points, you can find these 2 points and solve them. Sorry, I got distracted because it's my turn to play Ticket to Ride, which is an online game I play with a friend of mine. But anyway, it popped up in my thing. I need to disable my notifications, I guess. Anyway, instead of having to find 3 points by plotting randomly, you could just find the 2 ordered pairs. You could just find, what happens with this equation when x equals 0? What happens with this equation when y equals 0? And so we're going to do that right now. We're going to do a couple more problems here in the book. We're going to take a look at example 4. So let me go ahead and pull up another page. Nope, did I do that one already? I may have done this one already. Nope. Okay, good. All right. So we're going to look at example 4 at the bottom of page 331. And as soon as I get the stuff here, there we go. All right. So the equation is 2x plus 3y equals 6. All right. So remember, we're going to find two ordered pairs. And what we're going to do is we're going to find the ordered pair when x equals 0. And we're going to find the ordered pair when y equals 0. So the cool thing is that when x equals 0, it cancels out this term because 2 times 0 is 0. So if it cancels out that term, I would be left with 3y equals 6. And of course, if we divide both sides by 3, then we get y equals 2. It's pretty simple to do. We can even do it in our heads. All right. Let's take a look at what happens when y equals 0. So I'm going to rewrite the equation, 2x plus 3y equals 6. Well, now, if y is 0, that term right there cancels out. You can even think of it as canceling out like that if you want to. And you're left with 2x equals 6. So when you divide both sides by 2, x equals 3. So now you have the ordered pair 3, 0. So we have these 2 points. We have the point 0, 2, and we have the point 3, 0. These are easy to graph. 0, 2 is right there. 3, 0 is right there. And then we grab our ruler. We connect them with a, whoa, what happened here? Hang on a second. Sorry about that. My finger apparently hit something. Oh, now it's not drawing for me. Hang on a second here. There we go. And so then we connect these 2 points just like that. And there is our line. Graphing with the intercepts is the easiest way to graph an equation. And so if you can get comfortable using that, great. If you want to use the plotting multiple pairs, multiple points, you can do that as well. All right. So the next thing that we're going to talk about is the idea of a slope. And on page 333 in your book, we're going to talk about the slope. The slope is simply how steep your line is, okay? I'm going to pull up a blank page to demonstrate to you what we're talking about in terms of steepness of the line. So let me go back here and see if I can find or create a blank page. Here we go. So, in general, a line will do one of 4 things, and it shows us this on page 333. When we graph a line can go up or it can go down, and it can go, you know, up slower or faster. It could go up like that. It could go down like that. Those are examples of lines going up or down. They could also be horizontal, which means they don't go up or down, and they can be vertical. That's supposed to be straight up and down. Kind of hard for me to draw. I didn't use my ruler. So these are the 4 ways that lines can appear when you graph them. Lines that go up from left to right, like this first example, we say that their slope is positive. It's a positive number because slope is a number that represents the steepness of a line. So you can probably figure out then that a line that is going down from left to right has a slope that is negative. In a horizontal line, like the one I have up here, the slope is 0. It's not positive, it's not negative. And a vertical line has no slope. We may call it undefined. That's a term that we use in mathematics to when we talk about a line that has no a slope that doesn't exist. We call it undefined. So how do we find the value of a slope? How do we determine mathematically, what that number is. Okay, well, the way that we do that is we use a formula for slope. By the way, the letter that we use to represent slope is the letter M. And the reason for that is because that the French word for slope, which I don't know what it is offhand, but I know that it starts with the letter M. One of my students figured that out a few years ago. So we have a formula for finding the slope of a line. And the formula is very simply because when we graph a line, we've got 2 points at least, okay? And we're going to pick 2 of the points, regardless of how many there are, we'll pick 2 of them. What we're going to do is we're going to find the difference, and of course you should remember difference means to subtract. We're going to find the difference between the y values and then divide it by the difference in the x values. So here's the equation for the slope of a line. M equals y2 minus y1 divided by x2 minus x1. That is the slope formula. It is on page 333 in the yellow box near the top of the page. So let's apply this to find the slope of a line. Let's look at example number 5 at the bottom of page 333. That's example 5, not an S. Example 5, it says, okay, we've got a line and it goes through the point -1, -3, and it also goes through the point 1, 5. And we want to find the slope of this line. Now, folks, all we've got to do is we've got to plug the values into the formula and find the solution. But we need to be careful because if we're not careful, we might mix up our values. So I'm going to use red to denote what we're doing here. Now, this is our first point and this is our second point. And the only reason I'm calling them first and second is because that's the order in which I wrote them. I could have called this, the point on the left, I could have called that my first point, and the point on, I'm sorry, the point on the right could have been my first point, and the point on the left could have been my second point, and it doesn't matter. It will still work out, okay? Now, each of these points has an x value and a y value. So because I designated this first point, -1, -3, as my first point, this is the x value of my first point, and this is the y value of my first point. See how I did that? This is how I delineate between, or distinguish between my x and y values. So this is the x value of my second point, and this is the y value of my second point. And again, I want to stress that if you had these backwards, if you let the 1, 5 be your x1, y1, and the -1, -3 be your x2, y2, it still works. That's the nice thing about it. But you can't switch the letters around, okay? It's alphabetical, x and then y. So now that I've distinguished my x and y values, I'm going to plug them into the formula. M equals y2, y2 is 5, minus y1. Now be careful here, we're subtracting a negative number. I'm going to put it in parentheses just to remind myself that it's a negative number. And then the x2 on the bottom is 1, minus x1 is -1. Okay, very important that you're careful with those signs, because we know that when we subtract a negative, it's the same as adding a positive. So this is really going to be 5 plus 3 over 1 plus 1, which is 8 over 2, which is, oh, I'm running out of space. Can't write down there, so I'm going to do it up here. Our slope is 4. And it's that simple. We just plug in the values for x1 and y1, x2 and y2, and we grind out an answer. It's not hard at all. All right. Grab a quick drink here. Love my iced tea. All right. Now, let's pause for a moment. And the nice thing about this being on video is that you can pause it on your own, but I just want to recap. So we've talked about graphing lines 2 ways. The first way is by making a table of values and picking values for x and plugging it in. And of course, to do that, you need to solve the equation for y, if it hasn't been already. And then you pick x values, you plug them in, and you find the corresponding y values, you generate some points, and you graph them. The second thing that we did is we talked about graphing lines by finding the x and the y-intercept. Now remember, the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. Pretty simple. And then we've talked about the slope. The slope is the steepness of the line. How steep is the line that goes through these 2 points, -1, -3, and 1, 5? Well, it has a steepness of 4. And by the way, you could write that as 4/1 if you wanted to. That would be fine as well. All right. So now, let me pull up another blank document. I want to talk about, we're on page 334. Now, by the way, my book is over here. That's what I keep looking at. You probably figured that. Graphing linear equations by using the slope and the y-intercept. Okay, so that brings us to that equation that I told you about called the slope-intercept form. So we're going to take a look at this. Come on, here we go. The slope-intercept form is the equation y equals mx plus b. Remember, we just got done understanding that m is the slope. And this is a new designation for you. We know what the intercept is, but you didn't know that we're going to let the letter b represent the y-intercept. Okay? So when we have an equation solved for the letter y like this, the number in front of the x term is your slope. It tells you how steep the line is. And then the constant, the letter b in this case, and it will always be b in a slope-intercept equation, that's the y-intercept. That's where your line crosses the y-axis. So that's a great place to start, because if the line is written in slope-intercept form, it tells you a point and then it tells you a slope. So we're going to take a look at an equation. I'm going to demonstrate example number 6 in the book. There's a procedure in the box immediately preceding it on page 334. I'm not going to read that to you because you guys are intelligent enough to read it on your own, but I'm going to use that procedure in order to graph the line. So let me pull up a new graph paper. And we're going to look at the equation y equals -3x plus 1. Let me get the marker that I'm comfortable with. Okay, so, no. Here we go. So we're going to do the equation y equals -3x plus 1. All right, now I want to remind you that that number in front of the x term is the slope. It's a negative number. So that means right off the bat, because the slope is negative, we know that the line is going to go down. Just informationally, if you graph it and the line doesn't go down, you've made a mistake. Okay? And you might want to write your slope as a fraction. So the slope is -3/1. And the reason that's important is because the number on top tells us whether to go up or down, and the number on the bottom tells us to go left or right. I'm going to work you through this, and you're going to see exactly how it works. Remember that the b is your y-intercept. So right off the bat, we know that we have a point on the y-axis at 1. Hopefully you guys can see that. Okay. Now the slope is -3/1. Now let me remind you that the negative number means it's going to go down. That's your y value. But the +1 on the bottom means it's going to move in the positive direction. So starting at our y-intercept, we're going to go down. And here, let me make this even a little bigger. And I'm going to change the color so you can follow it. So from the point that we started with, we're going to go down 1, 2, 3 units. And then we're going to move to the right 1. And there's another point on our line right there. We can do that as many times as we want. We can go down 1, 2, 3, and then we move to the right. So we're going down and to the right, down and to the right, down and to the right. And you can see that those points are in a straight line. I don't know what's beeping all of a sudden. I don't know what that was. I'm so sorry, but hey, you can tell I'm not staging this or editing it, so I apologize for that. That was very strange. Anyway, I also want you to understand, I want you to see this. When we have the slope of -3/1, that negative sign you could even think of it as being on the bottom. I talked about this one other time, but when we have a fraction with a negative number on it, the negative sign is in the top or the bottom, but not both. The reason that this is important is because if you wrote it with a 3 on top and a -1 on the bottom, that means it's going up 3 and then it's going to the left 1. So from that point again, we could go up 1, 2, 3, and then we could go to the left 1, and there's a point. Go up 1, 2, 3, and to the left, there's another point. And you can see that all of these points, where did my ruler go? All of these points are forming a line. I lost my ruler. All right, well, I'm going to try and draw a straight line here. I'm probably going to fail miserably, but all right, well, here we go. You guys are about to see that I can't draw. Anyway, so we're going to connect them with a nice straight line like that. So that is the graph of y equals -3x plus 1 when you use the slope and the y-intercept. We'll do another one. Don't worry. I'm sure that you guys would like to see another one. So if you need to look at this a little more carefully, pause the video and take a look at it and then come back. And I am going to move on and show another one. Let's take a look at example 7. This is a great example. I like this one, and this one is going to be very helpful for you guys. Come on. So let's do this. Okay. So the equation is 4x, I'm going to start up here, 4x minus 3y equals 9. Okay. Now we need to get this into slope-intercept form first. So we need to solve it for the letter y. So I'm going to do that quickly. You should be, I'll walk through the steps, but you should be able to follow this. So I'm going to subtract 4x from both sides. When I do that, oops, this will cancel. I'll be left with -3y equals, put your x term first, -4x plus 9. Now I'm going to divide both sides by -3. When I do that, I get y equals -4 over -3 is a positive 4/3 x. Positive 9 divided by -3 is -3. Okay, so this is the equation that we're going to graph. I got to turn off my notifications. All right. So y equals 4/3 x minus 3. You might want to identify off to the side. Your slope is 4/3, which is a positive number, so that means your line is going to go up. And then your y-intercept is -3. First thing you do is graph that y-intercept, -3, which is right down here. Now remember, it's a positive 4 on top. That means you're going to go up, and then it's a positive 3 on the bottom, which means you're going to go to the right. So from the y-intercept of -3, you're going to go up. I'm going to change the color again so you can follow me moving up. Go up 1, 2, 3, 4, and then to the right 1, 2, 3. And there's a point on your line. Up 1, 2, 3, 4, and to the right 1, 2, 3. There's another point on the line. You don't have to do it this many times. I'm just showing you for practice. Up 1, 2, 3, 4, to the right 1, 2, 3. And you can see that those are forming a straight line. Now I want to remind you that that slope of 4/3, you could also think of that as a -4 over a -3, which means you could also be going down and to the left. So let me show you that. Down 1, 2, 3, 4, and to the right 1, 2, 3, and there's another point. So you can see all these points, and again, try and draw them with a nice straight line. Not the greatest at this, but that is the equation, or that is the graph of the equation. Y equals 4/3 x minus 3. All right, not too bad. Okay. We need to talk about one more thing, and that would be horizontal and vertical lines. So example 9 on page 335 asks us to graph two equations. It says, well, I gotta edit. Come on. Where is it? Here we go. It asks us to graph the equation y equals 2. Now, ladies and gentlemen, when you have an equation where it only has one variable, whether it's x or y, what that's telling you is it doesn't matter what the x value is. In this case, it doesn't matter what the x value is, y will always be 2. So in other words, if you wanted to make a table of values, x's and y's, you can pick your values for x, like 0, 1, -2. Y is going to be 2 for all of them. And when you graph those, you'll see there's 0, 2, there's 1, 2, there's -2, 2. You can see that we're forming a horizontal line. Okay? So, when you have y equals a number, any number, that is a horizontal line. Okay, so you can probably see where this is going. I'm going to do the same thing over here. What if I have x equals 5? Same idea. If x equals 5, it doesn't matter what you pick for y, x will always be 5. So say you pick 0, 2, and -3, x is always going to be 5. So when you graph 5, 0, 5, 2, 5, -3, you can see that you have a vertical line. So anytime you have anytime you have x equals some number, that will be a vertical line. All right? Again, pretty straightforward. So what I would encourage you to do is I've designed the homework. This is a good introduction to this lecture. We're going to need to spend some time on Tuesday going over some of this stuff and going a little deeper into some of the problems that I'm not going to get to right now, because I know it's hard to learn just from a video. But I would encourage you to work on the homework in section 6.6, and then on Tuesday, at the beginning of class, I'll go over any questions, and we'll go a little deeper into this section of 6.6 before we move on to the next section. All right? So I hope that you all get an opportunity to watch this video. I do want to tell you that it seems like Kaltura takes a long time to get videos uploaded. So I'm actually going to upload this to Kaltura, but I'm going to upload it to my YouTube channel as well, and send you guys an email with the link to that YouTube channel so that you can see it a little more quickly. All right? So I'm going to go ahead and stop the share. I hope that, that this will be helpful to you. Again, very sorry that I had to cancel class on Thursday. I do not make a habit of canceling class, especially in just the second week of the semester, but life got in the way, and that's okay. So I hope you guys have a great weekend. I hope that you stay safe and healthy, and I will talk to you on Tuesday morning.